Okay, Assalamualaikum and very good morning to all of you. I hope that you are doing okay. Even though that today is public holiday, I really hope that you can spend some time to pay attention to my live lecture notes here, live lecture session here. Because this is an interesting topic, which is we call it as equilibrium of particles. Okay, so why engineering is really get in touch with particles. We do a lot of analysis regarding particles and associate it with rigid body. Okay, because that kind of analysis is vital in order for engineer to create something new, especially new products or new design regarding building, as well as manufacturing process. All right. So today's topic is regarding this topic, yaitu equilibrium of particles. All right. So the learning outcomes for today's topic is identify. Okay, you can identify the force system. Okay, the force system. Okay, the force system using the concept of particle equilibrium. Right. And then you can solve the force system using the concept of particle equilibrium. Okay, solve the force system. You identify first, and then you solve. And then the application of particles equilibrium concept in engineering involving into dimensioning problem. And then you can use the equation summation fx equal to 0 and summation fy equal to 0 in order for you to settle this kind of problems regarding particles. Okay, in situation like hoisting mechanism and cables. Now what is particle? According to this slide, a particle is a body whose rotational aspect, okay, are not of interest at the moment. This is the case, of course, when the body itself is extremely small, so that we think of it as a single point at which all its mass is concentrated. Now, what do I mean by particle is that, let me give you an example. Let's say a car, right? So a car is actually not a particle. They are large objects. They have certain size and shape. But let's say that you are required to do analysis of a bridge where a lot of cars passing through that bridge every single day. Now, it doesn't matter whether you are driving a Toyota, a Honda, or even a Proton, or a Mercedes even. It doesn't really matter. What is important is that weight of that vehicle, that what matters. Okay, the weight of the vehicles. Now, so if you are doing a bridge analysis, we are interested in a particle. We are not interested in a particular types of car, the shape of the car, what is the accessories of the car, the size of the car, the types of the car. We are not interested in its shape or whatsoever. We just interested in its weight, right? So in this case, a particle assumption makes the analysis for that whatever engineering problem that we are dealing so much easier. In short, particles is actually really a concentrated mass. All right, a concentrated mass. I want you to understand this. A particle means that it is a concentrated mass. You don't care about the size, you don't care about the types, you don't care about what kind of car you are driving. You just interested in the mass, the concentration of the mass. Okay, we're just representing that particles in a small dot, and that is the particle assumption. Okay, so often we take a large body and shift all its mass to its center of mass. This is what I call our concentration of mass at the center, and just look at the motion of the center of mass. All right. So I hope that you clear what is particle is all about. Now, the next term that you need to understand is what is equilibrium. Now, equilibrium can be thought as an unchanging or stable condition. Okay. All the bodies that are at rest are in equilibrium. Now, take a look at this particle. This is your particle here, concentrated of mass here. Is this particle in equilibrium? Okay. Due to these forces here, 10 Newton from the right and then another 10 Newton to the left. course, it is in equilibrium, okay? Because according to Newton's first law, a particle originally at rest or moving in a straight line with constant velocity will remain in this state provided that the particle is not subjected to an unbalanced force. So this is 10 Newton and then counter by this again 10 Newton in different direction. So in the end, this particle is actually in equilibrium. Simple, right? Okay. Now, the particle equilibrium, the SOP that you need to aware when you are trying to solve any kind of particles in equilibrium. So you have to know that the particle is at rest or moves with constant velocity is actually in equilibrium. Now, this requires that all the forces acting on the particle form a zero resultant force. Okay, this is the keyword. In order to account for all the forces that act on a particle, it is necessary to draw free body diagram. Now, suppose that you have forces, okay, a lot of forces acting on this particle. So to prove that this particle is in equilibrium, you need to do some sort of analysis and ensuring that the resultant force acting on this particle is equal to zero. So to do that, first of all, you need to identify or draw free body diagram. Okay, and then next is the use of coplanar and concurrent force formula methods here, which is the summation of force in x and y direction is equal to zero. We are dealing with two dimensions here. Okay. Now, this is the overall procedure for you to solve any kind of problem regarding the particles in equilibrium. Okay, as I said before, you need to draw free body diagram. Okay, this is the configuration of coplanar, all forces acting in one particle here, in one plane at the same time. Okay, so this is your particles and all the forces here acting on this particle. So your free body diagram, first of all, you need to draw the x and y axis. Okay, label all the unknown and known forces, magnitudes, and its direction. Okay, suppose that you have F1, F2, F3, and F4, and somehow F2 here is unknown, so you have to label it. Okay, if you have angles here for each respective force, so please label it so. So please label it too. The sense of the unknown forces can be assumed. Okay, or the arrowhead representing the position, the sense of the direction of all the forces. Now, number two is quite straightforward. You just utilize the use of formula summation fx equal to 0 and then summation fy equal to 0. Okay, in case of spring, okay, this second second statement here, components are positive if are directed along the positive x-axis here. So starting from this origin of particle moving to the right, this is positive x-axis. Moving to the left, this is your negative axis for x. Okay, same goes to y and y here. This one is positive, this one is negative. If the system involves spring, so pay attention to this one, then apply force is equal to Ks to find the spring force. Okay, this is your spring force. Using the formation of spring. Okay. So one distinguished features that you need to understand about spring is that you can stretch it or even you can compress it. But in the end, the spring will return to its original position. Now, we will discuss on that later. Okay. Suppose that this particle here, okay, we have three forces acting on that particle. So this is your x-axis and y-axis here. All right. By utilizing the formula for equilibrium, which is summation fx equal to 0, summation fy equal to 0. So you do the trigonometry solution here. Okay. You resolve the force, okay, the related forces here. And then you will put R as unknown and the whole summation here is equal to 0. Same goes to Fy, okay. So you will notice that this Fy summation is clearly give you 0 as the answers here. So it just leave R here to solve for X exists. So you will get R equal to negative 13.86. So in terms of how you draw the magnitude of R here in terms of the vector sense. So initially R is pointing to the right. So your answer is actually negative. Okay, there are two things that you need to consider. First, if you insist to put the direction is on the right, so your magnitude here should be in negative. Otherwise, you just change the direction of the supposed R here. Just follow the final answer here. Then this is your magnitude. All right. Never ever do this one. Okay, you change the direction of the R vector here. Then you maintain the magnitude value for R. So this one is cannot. Okay, you cannot do that. So far clear? Okay. All right. So we have some example here. This is some typical equilibrium of particles exercise. Okay, that you need to understand. Determine the tension in cables AB and AD for equilibrium of the 250 kilogram engine. Now, so you need to take a look at this example as a whole system. Okay, this is, we can consider this example here as a whole system. Now, you need to identify, first of all, you need to identify by look at this configuration, where is the concentrated of forces acting on that system. Okay, in this case, it is A. Okay, so A is actually your points of focus, or we can call it as the particles for the whole system. Now, to complete the solution here, all you need to do is, of course, by using, you need to draw the free body diagram first. Okay, so your free body diagram should be okay. Don't forget the axis X and Y here, and then you have your AB tension cable here, and AD cable, and AC as weight. So this is TAB, and then the related angle is 30 degrees. And then this is your cable TAD, and then this is your weight. Now, the weight given here is, the mass given here is 250. You just times it by 9.81. So, okay, you do the math. You will get the weight for this engine. And then the next step is by utilizing the formula, which is summation Fx and summation Fy. Suppose that you focus on summation of Fx first. So you do the math here. TAB cos 30 degrees minus TAD equal to 0. Then if you rearrange the statement, it should be TAD is equal to AB cos 30. Okay, suppose that this is your first equation. And then move on to summation Fy equal to 0. So it should be TAB here. TAB sine 30 degrees minus your weight here, 250 times 9.81. Okay. And what else? All right, so equal to 0. So you rearrange this statement, you will get TAB sine 30 equal to 2452. Okay, and eventually your TAB is 4904 Newton. All right. Okay. From the summation of Fy equal to 0, you will get the TAB value. So put this TAB equal to 4904 to this equation number 1. So you will get TAD, which is 4904 times cos 30, which is equal to 4.25 kilonewton. Okay, simple, right? Okay, but please adhere to the SOP, which is the first thing that you need to do is to construct FPD and then utilize this formula here. All right. But the first thing is you need to identify the concentrated or focus point here, which is point A, and your A here is your particles for that system. Okay. Now, example number 2, we have a series of system involving a lot of particles to be considered as a focus of forces. If the sec at A has a weight of 20 Newton, so you have sec A with 20 Newton weight. Determine the weight of the sec at B. Okay, determine the sec B, the weight of sec B, and the force in each code. And the force in each code, meaning to say your tension cable here, needed to hold the system in equilibrium position shown. Say, okay. What you need to do is that you need to identify the particles involved. I mean, the concentration of force can be we can assume that force that point as your particle. All right. So in this case, of course, it is point C and point E. So you have to draw two free body diagram here. Okay. Let's say that you focus on point E here. Okay. So your free body diagram here should be something like this. So this is your point E, and then this is your sec A weight, which is 20 Newton. Your sec A, okay, and then this is your code EG or cable EG, okay, with 30 degrees angle, and then this is your cable TEC with angle of 45 degrees here. All right. So do not forget to label the axis. Now, for less, right? And then move on to this one, point C. Okay, this is your point C. And then the forces involved here is the weight of sec B. And then your TEC here, okay? Pay attention to the direction of TEC here when we are focusing on particle C. Oh, sorry, TEC. Okay. And then your TCD, okay, your TCD here. So then the triangle constructed here is 3, 4, 5, and then your angle, your axis X and Y. So basically, this is your free body diagram. This one is for E, and another one is concentrated at C. Okay, how to solve it? Okay, just use the formula. Suppose that you are trying to solve the summation of fx here and summation of fy here for point E. Okay, for point E. So let me just put all the equations here. So point E, it should be summation fx is equal to TEG sine 30, right, minus TEC cos 45 degrees equal to 0. And then your summation Fy is TEG cos 30 degrees minus TEC sine 45 degrees minus WA equal to 0. Okay, minus WA here equal to 0. So you have equation 1 here and equation number 2 here. Suppose that you rearrange this equation into a simple one. Okay, so your TEG here is sine 30 equal to TEC cos 45, right? And the other one is TEG cos 30 equal to TEC sine 45 plus 20. So you can use any kind of mathematical solution that you like. Okay, suppose that you are using simultaneous equation. By using the equations, you solve the equation, solving the equation. All right. Maybe you decide to divide the statement of question 1 divided by question 2. So you do the math. So eventually you will get TEC is equal to 38.6 kilonewton and your TEG is equal to 54.6 kilonewton. All right. Now, we only get the information for TEC and TEG, which is TEC here and TEG, but we need to find the weight of the sac at B here. So, okay. Now, what we need to do next is to focus on the other particle, which is point C here. Okay. Let me just draw the free body diagrams. Okay. This is your TEC. And then this is your TCD, and then this is your weight for sec B. All right. This is 45, this is 345. Now, you will use this TAC value here from point A. Just put it here. Just pay attention to the direction here when you are focusing on C. All right. So, just let's put all the value. Summation fx is equal to TEC cos 45 minus TCD 4/5 equal to 0. Okay, your TEC here is 36.6. All right, leaving TCD to be found by you. Okay. And then summation Fy equal to TEC sine 45 plus TCD 3/5 minus WB, and then all equal to 0. So by solving the equations, eventually you will get the value for TCD and WB here, which is 34.1, and the WB is 47.8 kilonewton. This one is also in kilonewton. All right. So far so good, guys. Okay. Now let's move on to another example. Okay, this one is involving spring. Now, determine the required length of the code AC. This is your code AC. Okay, meaning to say that the question needs you to find the length of this code AC here. Okay, LAC. So that the 8 kilogram lamp is suspended. Okay, this is your lamp weight with mass of 8 kilo. Okay, in order for the system to achieve equilibrium, you need to identify the suitable length of length AC here, so that this 8 kilogram lamp can be suspended in equilibrium. All right. Now pay attention to this one. This is your spring. The undeformed length of the spring AB is LAB 0.4, and the spring has a stiffness of KAB 300 Newton per meter. Now, from Hooke's law, you know that the force of the spring is given by K times its change in length. We call it as X here. So your X here is actually the change in length, the elongation or the deformation of the spring due to force. Okay, this is your change in length in spring length. Okay. Now, the undeformed length of the spring, meaning to say the original length of that spring before it is imposed into force. All right. Now, let me just draw the free body diagram for this system. This is your X and Y here. And then you have your spring here, the force of the spring. And then you have your lamp weight. And then you have your force TAC, tension cable for AC here, 30 degrees. And then this is your force lah, all right? Okay, now by applying the formula, summation Fx is equal to summation FAB minus TAC cos 30 degrees equal to 0. Then, okay, from this equation, what I'm trying to say is that you can find the value of FAB, okay, FAB here. Wait. Let me check first. Okay, yeah, no. So rearrange this question. FAB is equal to TAC cos 30 degrees. So question number 1, and then do the same for summation Fy. TAC sin 30 minus your W lamp equal to 0. So you solve this summation Fy here. Eventually you will get TAC is equal to 157.0 Newton. Okay, then just put this TAC value here into here, then you will get FAB is equal to 136.0 Newton. Okay. Now, remember the Hooke's law? Your spring force is actually defined by your stiffness of the spring and the elongation of the spring. Now, so your force of the spring due to this, you use that formula, summation Fx and Fy. Eventually, you find the value for force AB, which is 136 Newton. Okay, and K is given, which is 300 Newton per meter. Okay, 300 Newton per meter. So you will find your X should be 136 divided by 300 equal to 0.453 meter. Now, this is not, what I'm trying to say is that this is your spring, change in length of the spring due to the force here, 136. Okay. So, please remember that the questions need you to find the length of LAC here. Okay. So to continue the solution is you need to utilize this X value here. Okay. And put it into here. So your LAB here, okay, from point A to point B is your total stretch of spring here. We can label it as LAB. Okay. So your LAB is actually contributed by the undeformed spring, undeformed length of the spring. Okay. Length plus this X. Okay. So your undeformed length given by the question is 0.4 meter. Okay, 0.4 meter. Then your X here is 0.453. So your LAB is 0.853. Okay. Now, take a look at this picture here. Pay attention here from point C up to point B. Length is 2 meter. Okay. Now that your LAB is, what is the value? 0.853. Okay, 0.853. So you will know that this remaining length here is it's supposed to be 2 minus 0. 0.853 meter. So it is actually 1.147 meter. Okay. Now, by utilizing the triangle construction, okay, you will notice that you can construct some sort of triangle. So this is your 1.147, this is your 30 degrees. And then this is your required LAC length. Okay. So use cos 30 degrees, which is equal to 1.147 divided by LAC. So in the end, you will find the value of LAC, which is equal to 1.32 meter. Okay, this is your solution. Okay. Can you follow, everyone? I hope that you can follow the solutions here. Okay, involving spring. Okay, let's move on to another example. Okay, this one involving truss. Okay, truss member. Now, this one should be simple. Okay, again, you need to draw FPD, but please pay attention to the question. The members of a truss are pin connected at O. So this is your particle concentration. Determine the magnitude F1 of F1 and F2. So you have two unknowns for equilibrium. Set theta equal to 60 degrees. Okay, so let's construct the FPD for this question. So your FPD here is F2, F1. Okay, F2 and F1, F2 and F1. Your F1 is 60 degrees. And then yours, okay, 70 degrees. And then you have 5 kilonewton here with 300 degrees. And you have 7 kilonewton here with 3, 4, 5 arrangement. 3, 4, and 5. Okay, the next step is simple. You just apply the formula. Summation Fx equal to 0. Okay, you just resolve all the forces here. Okay, F2 sine 70 minus 5 cos 30 degrees plus F1 cos 60 degrees minus 7 4/5 and it's equal to 0. Do the same for Fy. So it should be F2 cos 70 degrees plus 5 sine 30 minus F1 sine 60 degrees minus 7 3/5 and equal to 0. So solve the equation, solve it. Okay. You can solve it any way you like. So you will find that the value of F1 is 1.83 kilonewton and your F2 is 9.6 kilonewton. So that's it. Simple. You just draw FPD diagram. Don't forget the X and Y axis here, and then use this formula equal to 0 due to equilibrium. So you will find F1 and F2. Okay. So far so good. Okay, good. Now, example number 5 here. Again, we are dealing with spring. The spring has a stiffness of K 800 Newton per meter, and unstretched length of 200 millimeter. Okay. So determine the force in cables BD, the force in cables BD and BC when spring is held in the position here. Now, so take a look at this given dimension here. So this is actually vital for your calculation to solve the unknown here. Okay. So your LAB here, your 500 millimeter here is actually LAB. Okay. So LAB is actually contributed by your unstretched length of spring, which is 0.2 meter, plus the change in length of spring due to the force later. Now, so your change, I mean, you can directly get the x value here, okay, which is x is equal to 0.5 meter minus 0.2 meter. So your change in length of the spring is 0.3 meter due to, maybe for this case, due to tensile forces, all right? And then from here, when you find the value of x, so eventually you will find that you can use this Hooke's formula for spring, which is F equal to kx. So your k here is given as 800 Newton per meter, and your x here is 0.3. So what I'm trying to say is that you can find the value of force of the spring due to these inputs here, okay? So it should be 240 Newton. Okay, so this is your force spring. Now, let me just draw the force, the free body diagram. Okay, free body diagram. Don't forget the axis here. This is your spring, FAB. Okay. This is your cable, TBC. And then this one is your TBD. So the angle is involved here is, okay, TBC 400, and then you just apply the theorem Pythagoras here. So you'll find that this one is 0.32 meter. Okay, this one is 0.4. This one is 0.4. Okay, 0.3, 0.4, and this one is 0.5. Okay, so just put it in the value here. This one is 0.4, 0.3, and this 0.5. This one is 0.4, 0.4, 0.32. Now, use formula. Summation fx equal to TBC 0.4 divided by 0.32 minus your FAB here, which is 240 Newton, plus TBC 0.4 divided by 0.5, and all this equal to 0. Do the same for Fy. So TBC 0.4 divided by 0.32 minus TBC 0.3 minus 0.5 divided by 0.5 equal to 0. So please solve this equation. So you will get the value for TBC is actually 145 Newton and TBD 171 Newton. Okay, so that's it. Okay, I'll give you so many examples regarding the force in equilibrium, particles in equilibrium of particles. So I really hope that you can understand the concept and the use of particles here and the condition of particle whenever you are dealing that particle in equilibrium. Okay, so I think that's it from me. I hope that you understand the concept. And if you have any question, you can contact or message your lecturer regarding this kind of topics. So that's it. And thank you very much. Bye-bye.